Hello, everyone. Welcome to our webinar where we will advertise an internship opportunity at the University of York, and in particular at our Institute for Safe Autonomy, which is a pioneering institution looking at safety of mobile and autonomous robots and intelligent systems in general. This is an opportunity that has been made available to us by the Royal Academy of Engineering via the Google DeepMind Research Ready program, and we are very, very proud to be able to be part of this scheme. My name is Ana Cavalcanti. I am an academic lead in the Institute for Safe Autonomy, and I am here with several colleagues representing two groups inside the Institute for Safe Autonomy. The first is RoboStar, which is actually a center of excellence on software engineering for robotics, with presence across the world in 6 countries across the world. I'm the director of RoboStar. And I also have colleagues here from SAINTS, which is a pioneering CDT, Center for Doctoral Training on Safety of AI. So we are both very, very proud to be able to be in a position to welcome a cohort of 12 fantastic undergraduate students to work with both of us during the summer. So today, I am going to tell you more about this scheme and who we are, eligibility and how to apply, SAINTS and example projects, RoboStar and some of our example projects, the structure of the internships, and then there will be some time for questions and answers at the end. So this scheme is a partnership between the Royal Academy of Engineering, Google DeepMind, and the AG Foundation. So targeting a particular group of undergraduate students, and with a presence in 12 institutions across the UK. This particular program that I'm presenting today is going to be implemented by the Institute for Safe Autonomy and the Department of Computer Science at the University of York, and as I said, in particular, the RoboStar Center and the SAINTS CDT. The topic of our internship program is design, verification, and assurance of intelligent robots. This is not the first time that we run a program of this nature. York houses Your Robots, which is a community of academics working in the area of robotics. And for many years now, we have run some sort of internship program and have been very successful. It's been a very rewarding experience, both for the students and for the team here. So our team has seen students doing extremely well in these internships and going on to do either further studies in the area or getting jobs in the area and really experiencing and enjoy the opportunity to be here with other researchers, with PhD students, with research assistants, and really understand and contribute to the evolution of robotics. So this scheme, as I said, in this scheme, we will accept 12 students from across the UK. They will be supervised by members of RoboStar and SAINTS, working as a cohort over 8 weeks with a generous stipend and even support for travel and accommodation if needed. Working as a cohort means that the group will work together in a particular structure of the program, contributing to the overall goals of RoboStar and SAINTS, helping each other and collaborating with the whole team. The experience will provide them with an opportunity to learn more about AI techniques, about AI tools, about AI research, and really enrich their CV and their outlook in the area. So I will now pass on to my colleague, Catherine Smith, who will tell us about eligibility and how to apply. Catherine, please.
Thank you, Anna. Yes, hello, everyone. My name is Catherine Smith, and I'm the Student Engagement Manager here in the Department of Computer Science. So as Anna says, I'm going to be talking to you about the eligibility for the scheme and how you can apply for it. As you know, if you've looked at our web pages and from what Anna said previously, this is a really exciting scheme for us to be involved in because it's a way that enables us to attract people from a wide range of different backgrounds that we feel are underrepresented in computer science and in areas of AI and robotics. So to that end, it does mean that we do have some eligibility criteria, which we like you to take a look at those and to ensure that you do meet those eligibility. But it does mean that we are very excited to be able to attract people from socioeconomically disadvantaged backgrounds and from other areas that are underrepresented in our field. So first of all, in terms of who you are and where we are looking for UK home students only, unfortunately, this does mean that in this particular circumstance for this funding, we aren't able to accept students who are paying international fees. So we do need to make that clear. And in this instance, it is for UK home students only. But the scheme is open to students who are currently in the Department of Computer Science here at York and all universities across the UK. So from a wide range of backgrounds, a wide range of courses in universities right across the country. So there are some essential criteria that you do need to be mindful of. The first one, as I've just touched on, is that you must be paying undergraduate home tuition fees, or if you have recently graduated, that you did so. You need to be in your penultimate or your final year of undergraduate study, or you've recently graduated. And finally, you have a right to live and work in the UK. And that is something that if you are shortlisted and we do offer you an internship with us, then that is something that we will work with you with those particular checks. Okay, moving on to the academic criteria, all of these are required as well. So you are on track to achieve a 2-1, or you have recently obtained a 2-1 degree in your undergraduate studies, and you have been studying computer science or a related subject. One thing that's really important is that you must have not completed, you are not currently studying, and you're not holding an offer for postgraduate study. So again, to be mindful of that if you are thinking of applying for this particular program. Okay, Anna, next slide, please. As I mentioned, we have some socioeconomic criteria here, and these are particularly important because it does ensure that you are eligible for this particular scheme. So you must meet one of these following criteria. So firstly, you are or were, if you've recently graduated, in receipt of full state support for maintenance during your undergraduate study. Perhaps while you're at school, you were eligible for free school meals. The third point there is that you live in an area in the lowest 2 deciles according to the postcode measures IMD or Polar. Now, we don't expect you to know exactly what those are, and we have got some links to that information on our web pages, but that is something that we can check when we've got your home postcode. So when you do apply, if you ensure that you have your full address there, then we can use your home postcode to check that on your behalf. The other criteria that we're looking for here, and again, it is just, I must stress again, it is just one of these criteria. Maybe at some stage you've been in local authority care. Perhaps you are the first generation of your family to study at undergraduate level, or maybe you are a refugee. So out of all 6 of those criteria, we are looking for you to meet just one of those. And when we go on to the application in a moment, information at the moment, how to apply, I'll explain how you can provide evidence of that. Okay, next slide, Anna. Okay, so that QR code there takes you to the application form on our website. To give you a bit more information about what we're looking for in the application, first of all, we're looking obviously for your personal details. Secondly, about your background in terms of how you might meet those socioeconomic criteria that we've just listed. Now, I must stress at this point, when you apply, we're not looking for that evidence. If you are shortlisted, we will ask for the evidence at that point. But you might want to take the opportunity at this point when you apply to think about getting that evidence ready in the event that you might be shortlisted. It will just help ensure that everything runs smoothly. On our application form, we actually say what we're looking for in terms of that particular evidence, so you can have a look at that on the form. The other information that we're looking at is that there's 3 documents that we ask you to upload. The first one is your transcript from your undergraduate studies, and that can be the most recent year of, and on the application form, we state there what we can accept in terms of that transcript. Screenshots are fine from your university portal, or you may wish to send us a PDF of another type of document that you've got. The second document that we're looking for is your CV. So what we're looking for here is details of your employment, if relevant, your interests, and anything that you've got, your interests and all the opportunities that you've managed to fulfill while you've been at university. Finally, the last thing that we're looking for is I beg your pardon, we're looking for a personal statement. And in your personal statement, we're looking for your motivation for applying. We're looking about what excites you in terms of the fields of artificial intelligence and robotics. And finally, why you want to do this scheme, what it is you want to get out of it, and the motivation for applying. Okay, we've got some information on timeline there. So in terms of applications, the application deadline is the 21st of March. So there is time there for you to get your application in. Notification of offers, we're looking at the week of the 4th of April for that. And in terms of the program duration, it's 8 weeks and it starts from the 30th of June and it goes through to the 22nd of August. Okay, now we're going over to Colin.
Good morning. Lovely to see you all today. My name's Colin Paterson and I'm the training director of the Saints PhD programme here at the University of York, and also a research lead in our Centre for Assuring Autonomy. It won't have escaped any of your notice that safe AI is particularly in the news at the moment. And I'm just going to share a couple of slides to tell you about what we're looking at before I hand over to my colleagues. So Saints is funded by the UK government, and we're looking at training 60 PhD students over the next 9 years who are going to look at how we ensure and assure, and there is a difference between those two words, which you'll find out when you're working with us, that the AI that gets deployed into the world is safe and remains safe throughout its entire life. And we've really got two themes across our research. The first is making sure that whatever happens after we've deployed our AI, that it remains safe as the world changes. And we call this lifelong safety. And the second challenge, the research theme that we're looking at, is increasingly autonomous systems. So as AI takes over the jobs that have traditionally been done by humans, how are we going to make sure that it's still doing the things we want it to do? To look at these themes, we've actually come up in the first instance with two challenges that we're looking at. And the first is how those AI systems are deployed into what we would call embodied AI solutions. So using robots to do things in the real world. So some real links with the things Ana was talking about there in RoboStar. The second challenge that we're looking at is about this interface between humans and AI and how it's going to change how we work across those boundaries, particularly important in things like healthcare, but also, as the picture below there shows you, things like air traffic control, how all of those things are going to change as we move forward. So a really exciting time to be involved in this type of research, and something that we're finding that huge amounts of partners are interested in working with us on. So this is a good opportunity to get you involved. So rather than me talking on, I'm going to hand over now to some of my colleagues who are going to tell you about some of the exciting projects that are examples of the sort of thing you could be doing with us through the internship.
I'm Victoria Hodge. I'm a researcher in the Centre for Assuring Autonomy here at York. We're a research group who work very closely with the SAFE CDT. So solar farms generate electricity in an environmentally friendly and sustainable way, but they need to be maintained to ensure that they're operating efficiently. For example, they could get dirty or sometimes they overheat. And these solar farms are vast. So the idea is that the Centre for Assuring Autonomy and Saints are together developing an autonomous robotics platform, which will go around and inspect and maintain the solar farm. And that will be done in collaboration with humans. So in essence, we're producing a research platform for AI and safety assurance work together. So the idea of this project would be that you would develop a simulation of a robotics platform the idea is that this would be produced as, you would produce a simulation world of our ISA solar farm outside, which you can see in the photo on the right. So some of our colleagues in the Institute for Safe Autonomy have laser scanned our solar farm. They produced a brilliant 3D model of the solar farm. Unfortunately, it's completely static. And for simulation of the real world, you need it to be dynamic. You need to be able to move things around and put things in it. So we need a realistic simulation that has things like hazards, such as we need to be able to change the weather. We need to be able to maybe add weeds that may grow up in amongst the panels, put birds in there, add rocks on the ground, and have cables trailing between the solar panels to produce hazards. So the idea is that the intern would be able to produce a simulation world. We actually have some robots that we use for this task, and we have some models of those robots. The idea is the intern could use whatever they like. They could maybe get some stuff off the internet. They could even produce stuff themselves, and they would produce a simulation of our solar farm. It wouldn't have to be an exact facsimile, but the idea is that we want something that's similar enough so that we can use it in our research work. So the outcome of this project would be the simulation platform for the research group and the SAINT students. We'd be able to do safety assurance work on that, and then we'd be able to investigate methods to ensure that when these robots and humans are working together to inspect a solar farm, there are no harms or risks.
Thank you, Colin. Hello, everyone. My name is Frank Soboczenski. I'm a lecturer here in the Artificial Intelligence group. And this project here would focus on determining radiation damage in biological data. So this is in cooperation with NASA Ames Research Center. And we have created a model that is able to classify certain radiation damage in cells, in cell nuclei data. On the left, you can see two examples of this cell nuclei with different radiation damage. And we developed this vision transformer model, this vision language model that is able to classify those different kinds of radiation damage. This project will now focus on the next stage of determining the explainability of the model and drawing this really out in terms of what you see on the right, using different explainability frameworks and therefore establishing what the model actually does and why it acts on its decision mechanisms, and therefore build trust into the model. And on the bottom, you can also see drawing out attention maps from vision transformer models to basically see and verify why the model looks at certain features and decides on what it is decided on. Thank you. Next slide, please. This second project here is focusing on a different angle on small language models. So those become more and more popular in terms of all the very great capabilities that the large models can do. And there's a field in artificial intelligence that tries to quantize those models, make them more effective for edge devices. And there has been quite some development in recent years. And this project will focus on those small language models, whether they run on, we have some examples here that run on iPhones via the Apple MLX framework, or that run on edge devices, as you can see in the top, like NVIDIA Jetsons. And those Jetson devices can be attached to drones, as you can see on the left-hand side. There's actually a Jetson attached to those drones, or run to determine other classification problems, as you can see on the right-hand side. This is a radiation particle detector that classifies those particles, and also wearable devices. So with those models becoming smaller and more efficient, they are able to run on really small edge devices. And emphasis on this project is also explainability and really drawing out not only the efficiency of those models, but also in terms of safety and in terms of explainability, and basically showcasing why the model decides on what it does. Thank you very much.
Nathan.
Yes, hello everyone. My name is Nathan Hughes. I am a research associate here with the Center for Assured Autonomy. And I'm very much focused on the sort of the human AI teaming aspect of things. So sort of now we're building these more complicated systems. How are we going to make sure that they're working for people and also alongside people? So in particular, I'm currently very interested in sort of aviation as a subject, because obviously the complexity of automation is increasing over time. We're starting to lead towards this idea about humans and AI working as teammates together. But sometimes we already know that sort of when people use technology, they work with technology, this can break down. It doesn't always work perfectly. And then if this happens a lot of the time, we can have sort of accidents, sort of risks become apparent. And then we have sort of incidents, problems, sometimes fatalities. And this is particularly important in aviation, which is where my interest is, because many of these accidents that we have seen, especially in sort of between pilots, tends to be some sort of breakdown between the technology that they're using in the planes. So when they're switching between sort of saying, I'm manually in control of the plane versus the plane flying for itself, there's sort of, we have these breakdowns here in terms of passover, this sort of thing. But whilst we know this is a thing that happens, we're not particularly sure on sort of how commonly this happens, particularly in that specific breakdown rather than anything else going on. And also on top of that, why are these breakdowns occurring? What is it about this sort of passing between control, the information that they're sharing with one another, what's sort of going on there? So the idea of being this sort of project is to say, well, we do actually have access to a lot of this information because the accident investigation reports that come out and get published are typically quite open source. They're sort of available online. So the idea of being, it'd be really useful for us if we could sort of go into this and sort of say, okay, what's some common themes here? Pull out these sort of key factors to say, when there's this breakdown between pilots and autopilots, what's going on, what was happening, who was involved, is it specific types of tasks we need to be sort of aware of? Essentially building to this idea of if we could understand what's going wrong now, as we continue to increase the complexity of automation and AI, we'll be able to have some sort of guidance for people to say, okay, we are aware of these problems, we're aware of these sort of the types of things that can go wrong, and build them in so that we can ensure that they hopefully won't happen moving forward.
Thank you, Nathan. Sepeedeh.
Thank you. Hi, everyone. Good morning. My name is Sepeedeh Shahbeigi. I'm also a researcher with the Center for Assuring Autonomy. Following on with the discussion, so the topic that we are also interested in is to use driving simulation for safe machine learning data sets. We know that AI has made autonomous driving a reality, but in order to make sure that these autonomous driving systems are operating safe, we need to have safe AI components as well. Part of this safety relies on the data sets that are supposed to capture the complex world around these vehicles. But it is very difficult to collect these data sets, and they are very costly and labor extensive. Therefore, one solution is to use driving simulations data. One such simulator is Carla, which I put a video here. Is an open source platform, and this is how it looks like. You can define a path for the vehicle to move around, or there are some autonomous algorithms that will make your car move around and collect data. Thank you. Next slide. So the tasks in this project can involve setting up Carla and collecting data sets based on our discussions, which includes the different times of day. For example, it is day, night, or different traffic types and road layouts and weather conditions. What we expect from this project, it can be a driving simulation platform for the center and sciences students to use, and it can contribute to safety assurance works of, especially the ones that focuses on data sets and considering robustness and making sure that data sets would not contribute to hazards in autonomous driving.
Hello, my name is Mark Sujan. I'm also based in the Center for Assuring Autonomy. I'm going to give you an example from healthcare, specifically looking at how we can use large language models to support healthcare safety investigations. Next slide. So in the NHS, we have changed the way in which we investigate patient safety incidents, of which there are way too many, I have to say. And we place now a focus on systems thinking as well as compassionate engagement of those affected by patient safety incidents. The challenge is, of course, to ensure that this is consistently done in investigations and also to provide feedback and education to our safety investigators. Next slide, please. So the project is in collaboration with the Health Services Safety Investigations body. They have developed a manual learning response review tool. And actually the tool is quite successful. Anecdotal evidence suggests, lots of people are finding it useful to review the evidence contained in the healthcare safety investigations about the extent to which systems thinking principles have been applied and the extent to which, for example, people have been compassionately engaged with, i.e. their needs have been appropriately considered. But the problem is it takes a lot of effort and resource, which is unfortunately something which in the NHS we do not have. And so next slide, please. The challenge really is, can we use large language models to somehow automate this process? And what we need to do is, first of all, develop some kind of evaluation framework, i.e. how can we assess the quality of the outputs of large language models when they review investigation reports, for example, for the extent of systems thinking and compassionate engagement. We need to consider information governance issues because these investigation reports will have confidential patient information and we can't just send it to a random LLM to the United States or elsewhere. Then we need to run the LLM, feed the investigation reports into it, interact with it, see how best we can prompt it, and then finally apply the evaluation framework. And the real beauty of this project is the impact is potentially quite significant because it could potentially be rolled out to the whole of the NHS, which would really make a really valuable contribution. Thank you.
Okay, thank you very much. I'll hand back to Ana now, and thank you very much for listening.
Thank you, Colin. I'll tell colleagues now about the RoboStar options. Thank you very much. Fantastic collection of projects there, beautiful examples. I'm now going to tell you a little bit more about RoboStar and some example projects that can be carried on with the RoboStar researchers. So, as I said before, RoboStar is a center on software engineering for robotics. It's led from York, from the University of York, but it has a presence in 6 countries. And we have here on the left an indication of the collection of partners that we have. We have partners in Norway, Germany, France, China, Brazil. In the UK, we have partners in Leeds, in Sheffield, in King's College London, and Thales. In particular, the partners in Germany and France are companies working in the area of safety testing and safety of autonomous railways. So they all have a shared vision, the shared vision that we should develop software for mobile and autonomous robots that are intelligent, especially the ones that are intelligent, using what we call a model-based approach. So students are already in the penultimate year or coming towards or even more advanced than that in their studies. They will have heard of models, but they are also aware that very often in practice, people, especially when they are innovating, they forget the engineering of their task and go directly to coding. And as already very advanced students, they will know that coding is just one particular part of the cycle of software development, of software engineering. So RoboStar has a very comprehensive end-to-end approach to developing software for intelligent mobile robots. And we have demonstrated our approach in several case studies, but in particular, I'm singling out here 3 of our main demonstrators, which is a firefighting drone, a UAV, a collection of robots for nuclear decommissioning, and an assistive robot for dressing that is being developed actually together with the Saints team, or members of the Saints team. So the idea is that coding and manual testing becomes a thing of the past, that what we really need to do when we are developing such a system and we are concerned about its safety, concerned about its operational reliability, wants to provide the sort of assurance that Colin and his colleagues were talking about, we need really to talk about models. We need to use a model-based approach. And then from those models, derive value, derive code automatically, derive tests automatically. And everyone around this wheel of partners here is tackling one of those aspects of how we can take value out of the models that we develop. So I don't have time to explain to you what are the kinds of models that we have in RoboStar. I have here just a picture to give you a flavor of what we're talking about. This is a picture of models for the control software, which is our focus. The control software needs to be our focus. It's the element of the robot, of the intelligent robot that we are developing. So we will recognize potential, if you have that experience, some block diagrams, some state machines here on the right. I absolutely don't need you to understand the details of this, but I just want you to know that we have developed a notation like of this nature. This notation is specific for robotic systems, mobile and autonomous robots, intelligent robots, and therefore it melds well with other notations. As I said, we have an end-to-end approach, other notations that consider the robotic platform, the environment, assumptions that we make about environment, assumptions that we make about human behavior, and so on. But with this picture here, I just want to tell you that what we need, if we're talking about an intelligent robot, is that we need to be able to capture in a model like this the intelligence of the robot, the component of the robot that is intelligent. Just like we have state machines or have class diagrams or have any form of model that you might be familiar with, the questions we have is how can we incorporate, how can we enrich these models to cover for the AI component as well? And when we do that, how then we can stay with the same sort of value? How can we then generate simulations, generate code, generate tests? That's the really exciting problems that we are tackling. We have tools, right? So absolutely, if we only had drawings of machines, of diagrams, those are not models. Models need tools, and so we have been developing a couple of tools, and we will talk about examples of projects that are based on both of them. Here on the left is a modeling tool that checks if the models are well formed, that can then add value by generating code, generating simulation, generating mathematical definitions of these models. And those mathematical definitions can then be used in other tools for us to be able to say something, to reassure some property of the system even before it exists. So here on the right, it's another screenshot of another tool that can pick up those diagrams and turn it into a mathematical theory that we can use to prove some properties of those diagrams. So this is the world in which RoboStar is operating. And we have here some examples. I've brought here for you five examples of projects that the successful candidates for these internships would be able to tackle and help us with. Really very exciting projects. So very briefly, what the problem we have here is that it's not easy to predict and control the behavior of AI components. And we need to do that. When we're thinking about safety, the safety is not a property of a neural network. Safety is not a property of the LLM. Safety is a property of a system. We can say that system, that robot is not going to bump into a person and cause some injury. That is a system property. It's not a property of just one component. And so we need to be able to predict and control the components and include them inside the RoboStar technology that has this overall view of what they are. We already have some ideas, so nobody needs to be scared. We have some ideas of how to achieve this. And what we are asking for will be help to put these ideas in practice and apply them in some exciting problems. So the first project here is models for AI components based on practical tools for training ANNs. So this, as I said, we have an idea about how to write these models. But there are a huge variety of different shapes of neural networks, for example. There are a huge variety of different tools for training neural networks. So what we would like is for someone to help us to identify the various structures of the neural networks and then create, based on the training tools, create then a RoboStar model of that artificial intelligence component. The task here would be basically about understanding the training tools, understanding their output, and then using our approach to gently use that output to define the model. It's really mostly about playing with the and learning about and making work the training tools for AI components. But neural networks is just one of the many artificial intelligence techniques that are around. So robot planners, so robot software has several components, and one of them is called a planner. There are lots, it's the exciting bit of the robot, many would say. It's where the AI would go, and there are lots of technologies that we can use for this planner. That part of the robot that decides, that robot moving around the world, that has a mission. How is it going to achieve that mission? There are technologies that we know well, that we use for this robot, for developing these robot planners. And again, we want to learn about the tool and how it integrates with RoboStar. So we have the idea of the work. We can help the intern that gets a project like this. And that would be all about learning these fantastic technologies of planning for robotics and bringing them into our fold. Another one, it's for automatic generation. I brought here a few more words in a slide about this project. It's automatic code generation for AI components. As I said, one of the main things is for us is that writing code by hand is a thing of the past. But again, the developing code for AI, there are several tools that do that, but it's the AI. How about the rest of the system? We, as our computer scientists, we want to make sure that roboticists can use our tools without having to become computer science themselves. So we need to make sure that we can integrate these specialized tools for AI with the specialized tools for robotics, and also demonstrate that in a real robot. So in this project here, we will be working with a real robot, a turtle bot or a drone. It depends on the experience of the intern. And the outcome would be a lot of infrastructure, libraries, frameworks for something called ROS, which is Robotic Operating System, which is widely used in the area of robotics in industry and everywhere, and allowing us to integrate the generation of code for the AI, for the generation of code for the rest of the system in exciting examples. So again, it's about the system view. Okay, the next project, I will pass on to my colleague Pedro Ribeiro, will tell you about his project on LLMs. Pedro, please.
Thank you, Ana. As I'm Pedro, I'm a lecturer here in computer science. I'm also a member of the RoboStar Center. And in the context of what Ana has been saying about models, the project I'm here proposing is about exploiting them to check for errors, generate code, simulation, testing, etc. So we can derive value from these models. But a question is, can we synthesize such models automatically? So remember, the idea is we're not coding anymore by hand, but instead we can use AI techniques to produce models that satisfy particular properties of interest, right? And these models, they need to be well-formed. So although they're diagrammatic, they need to conform to a meta model that define how they can be written. So there'll be some constraints on how, your states of your state machine are composed together, for example. So you can't just produce an arbitrary ill-formed model, otherwise that's not useful. So the idea of the project is to use LLMs to synthesize such models automatically, and then we can derive value from those models by using RoboStar technology, whether that's in terms of generating tests automatically, generating proof models, that is mathematical models that we can do some analysis over them, or generating code directly, and so on and so forth. There'll be other things that we could do in the future if we can generate such models at scale.
Thank you very much, Pedro. Your project makes my eyes shine, because we are saying people don't need to write code, people don't need to write tests anymore, it's all automatic. And now what Pedro's pursuing is, and actually writing the model, we can let the AI to do that as well. That's amazing. That's really, really very exciting prospect there that the community is pursuing, and Pedro's in a strong position there to help. And the only reason why they can do that, isn't it, Pedro, is because we can trust the AI to generate these models, and then we use the RoboStar technology to make sure that the models are all right. And that's absolutely great. Isn't that the idea, Pedro?
Indeed. So exploiting value from all the RoboStar technology with these models themselves, because we can analyze them and make sure that they are properly functioning.
Fantastic. I think I want to do that project myself. I'll see if Catherine lets me to register. Thank you, Pedro. I think the next one, the next example is integration of AI verification in RoboStar, and Simon is leading that side of the work. Simon, please.
Yes, so my name's Simon Foster. I'm a senior lecturer, part of the RoboStar Centre. So this project is about verifying of AI components in the context of one of these robotic software engineering models that we've been talking about. And so the idea is that we want to be able to provide guarantees for the behavior of neural network components. So for example, we might have a state machine based model for one of these components, and we want to show that as an alternative, a neural network component conforms to the specification that we have provided. And so the idea of this project is to make the use of symbolic logic reasoning techniques to allow that. So one of the tools that we saw earlier is a kind of mathematical proof tool called Isabelle. So it allows us to create mathematical descriptions for robotic software, and also use automated reasoning techniques to check whether the software does what we want it to, whether it fulfills its requirements, whether it's bug-free, and so on. And so this tool is going to be applying a number of different proof-based tools. We're using a tool called Marabou, which is a tool for neural network verification, and also a proof tool called Isabelle, which is one that we are developing here at York. And so a student who did this internship would have the opportunity to apply some state-of-the-art proof tools to a very exciting application, which is AI verification, which is something very new and something that hasn't received a lot of research yet. So I think a really good opportunity for a student.
Okay. Thank you very much, Simon. It sounds complicated, but you know how to do it, don't you, Simon?
Yes. So we've got a lot of experience with teaching this kind of technology. So yeah, we're confident that we can help students to understand how to apply it.
Okay, thank you, Simon. That's very, very exciting. I'm getting to the end here of our set of examples. I just wanted to say now a few words about how the RoboStar interns are going to work with us. There is a fourth member of the RoboStar Center, or academic member of the RoboStar Center here in New York as well, Álvaro Miyazawa, who unfortunately could not be here. But the four of us are going to be supervising these students together. So all the students are going to have support as they need from all of us. They will be allocated to one of the four of us, but they will have continuous support over the 8 weeks from all of us. We all have a good knowledge of the tools, of the techniques, and so on. And at no point these students will be left without support throughout the summer, because we'll be working together, encouraging the students to work together, but we as well working together with the students. And we're really looking forward to have a cohort of RoboStar students in 2025. Yeah. Okay, so thank you very much. These are examples that we will have of projects. I'd like now to conclude by telling you a little bit about the structure of the internships. These are all the internships across RoboStar and Saint. They all have the same structure. They all start on the same date, on the 30th of June. And the reason for that is that because the first week will be a week of training. The students will have to attend a set of talks, do some reading, follow some tutorials, potentially giving some short presentations as well. That week will be a week where we are going to make sure that the students get to know each other, get to know all of us, and then feel themselves in a very strong position to start in the project with all the support that they need. They all will have all the resources required for the project that's allocated to them. They will have a desk provided either in the Department of Computer Science or in the Institute for Safe Autonomy. We will have a social event at the start to get to know everyone. And then after that first week of training, then there is a structured program of work, a phase of problem elicitation, where the students will work with their assigned supervisor and others to understand what it is that they have to do. So these brief descriptions, if they were descriptions that is, oh, I don't quite follow that, I didn't understand that, don't worry. That will be a phase where we'll be working together, studying together, and making sure that you all understand what needs to be done. And then there is a phase of project execution, where there will be at least weekly meetings with your supervisors, and that I can say that my door is always open, and when people need me, I will make myself available as soon as I can, and I know that others here are in the same situation as well. And finally, at the end, this student the intern will spend some time documenting their results. We absolutely confident that we'll get some interesting research out of the students' effort, and then they need to be documented so that the next students, or the members of RoboStar, or the members of Saints, can take advantage of the work that they have done. And in the past, with our experience in RoboStar or robots, we learned that some of the students, they can even become co-authors of papers that we can go on to submit, which is something that can be a nice cherry on the cake in terms of their CV. Finally, there will be a final event in the penultimate week of August, which will be part of a conference that's happening here in York. It's called the Taurus Conference. And that's the robotics conference for the UK, and that in that final event, the students will participate and present a poster and get some prizes. Again, there will be support from all the supervisors for the definition of this poster, for the creation of this poster. You will present your poster in short presentations of 5 minutes or so to the other interns and to the other supervisors, and we will be giving prizes. Again, another opportunity to enrich your CV and to acquire some transferable skills in terms of communication and presentation of the work that you do here in the internship. So this is it. This is all we wanted to tell you about. And I'll be happy to answer any questions, and colleagues here around the room will be happy to answer any questions if anybody in the audience would like to ask.
We have one question that's come in. Perhaps you could take this one, Ana.
Okay.
What would help your application stand out? Is it skills or the reasons why you want to join this internship?
Why would make it stand out? Well, the eligible students, the first thing, of course, that they need to be eligible. Among the eligible students, we will be looking at evidence of good performance. And of course, motivation is important. But I would say good performance in their undergraduate course or in other activities of the same nature, I think would probably make the student stand out, and make the student having the background that we see that can fit to. We've seen today a variety of examples, haven't we? There are lots of interesting, all the way from playing with the tools for AI, to playing with simulators, to playing with healthcare applications. Across RoboStar and Saints, there is such a vast, and so standing out would be someone who has some sort of evidence that they have the skills in one of those areas. Any of them.
Thank you, Ana.
Can I add a little bit to that, Catherine? Is that okay?
Go ahead.
So I think that for us, the one of the things that really makes it stand out is enthusiasm, and that enthusiasm starts with your application and showing that you've spent some time looking at the sort of things that we're looking at. So we've given you a starter today by talking about Saints and RoboStar and our research here at York, but demonstrating why this in particular is of interest to you. What is it about this opportunity that you think is going to allow you to do things that you will find interesting? And if you demonstrate to us that you're interested, that will help us see your potential within the program.
Thank you, Colin. Oh, we have one more. Okay, the question about the requirement. Is it required that the applicant has at least a 2-1, so a first is eligible, or only people who have achieved just a 2-1? So that question's from Anthony. Anthony, it's at least a 2-1. So if you're in line for a first, that's brilliant. So yes, we are looking for at least a 2-1 predicted, or if you are a graduate, then you have achieved at least a 2-1 degree. In terms of the projects, how are they assigned to the interns? Is it based on strengths, etc., or something else? Anna, do you want to pick that one up?
I will pick that one up. Yeah, Christopher, thanks very much for that question. I'm very keen that people understand that. So we are following the guidelines of our funders. So we basically will, first of all, we will shortlist the students that satisfy the essential criteria. And after that, we will see, well, there was a question before, right, about skills, about enthusiasm and so on. When we choose the 12 students, then the 6 of the students will be allocated to work with Saints, 6 of the students will be allocated to work with RoboStar, and then there will be a discussion. The discussion would be, and if we will ask the students, where do we want to be? And we will respect the interest in as much as we can. And after they are allocated to the cohort, the Saints cohort, or the I don't want to start calling them Saints cohort and RoboStar cohort. They are the York cohort, the Institute for Safe Autonomy cohort. But you see what I mean. The students that we work with the Saints supervisors and the students that we work with the RoboStar supervisors, then there will be a discussion. We've seen some examples of projects. We will look at the background of the students. We'll look at the interest of the students. What do they like to do? And in fact, we've given examples of these projects, and some of these projects can be taken by more than one student. We will make sure that these students will be comfortable with in following the project, that they are enthusiastic about the project, and they have the background to do the project. And so that's why I was very keen and calling as well from the beginning to say those are example projects. Yeah.
Thank you, Anna. So we have another question which kind of leads on from this. And one of our attendees has asked, I'm strongly interested in automation and specifically LLMs. However, I don't have much experience or proof of work yet. Should I still apply?
Shall I take this one?
Colin.
So the answer is absolutely, you should apply, and you should say that they're the things that you're interested in. You should still evidence that. So you may not have done any work on it at the moment, but maybe you've read a couple of articles. Maybe there's a couple of application areas that you've seen that you think are particularly interesting or challenging. Maybe they raise safety concerns. Maybe how they're going to work with humans. What's it really going to mean when these things happen? They're questions that you're asking rather than maybe what the literature is showing. So yes, you can definitely talk to us about that. When you arrive here, we don't expect any of you to arrive knowing everything. That's not the point of the internships here. So what we'll do is in those first early weeks, we'll give you the materials that allow you to build your knowledge so you can contribute towards the projects. So whilst we've written out the projects here, there are aims, and as Anna says, they will be tailored to the person that we're getting to ensure that we get the best outcomes possible for you and for the work that's being undertaken.
Yeah, absolutely, 100%.
Thank you both. We don't have any more questions coming in at the moment. We'll just wait for a few seconds more. Does any of the... Oh, we have just another one come in. Just bear with me. Okay, it's Christopher again. Hi, Christopher. Is there anyone we should be able to get into contact about any extra questions about the projects? I'm not confident that I would be a perfect fit for some of them based on my current knowledge. So I would like to find out what I could do to prepare. Who would like to pick that one up?
Okay, at this stage, we cannot promise any particular project to anybody. I think what Christopher needs to do is to apply, to explain why and what he would be interested in doing. And then if Christopher, who's here keen asking questions and so on, hopefully gets shortlisted and chosen, then Christopher will enter into conversation to understand which project would be good for you in terms of having your background and your interest into account, and the example projects and perhaps others that we can devise to suit your interests and needs. And then we can start that conversation that you can perhaps prepare if you so wish. But we will repeat what Colin said. We don't expect experience. For example, thinking of LLMs, for example, there is a RoboStar project in the area of LLMs. That's Pedro's project. Pedro confirmed, if my understanding, we would be very happy for a student to learn what an LLM is, finding out about an interesting tool, learning how to use that tool, and then in that process of learning, using the problem of generating a RoboChart model, a RoboStar model, as the exercise to do that learning. That would be absolutely acceptable. Do you agree, Pedro?
Yeah, absolutely. I think that that's a nice suggestion. So even if you don't have the experience, I think this is an opportunity to learn more about it.
Yeah, so a concrete example for what Colin has already said, and we will not be imposing the students lots of pre-reading or anything, because what they need to be doing until the 30th of June is studying very hard for that degree to have the very best grades they can get in that degree.
Fantastic. Okay. Thank you, Anna. Okay, I don't think we have any more questions at the moment coming through. Okay, just to say to those who are attending today, if you have any questions that come to you before, after this, and you've got anything else that you want to ask, you can email us and we will get back to you. The email address is yourrobots@york.ac.uk, and that's spelled YOR robots@york.ac.uk, and we will get back to you with any questions that you've got. And I think any final words, Anna, from you?
I am writing the address that you've just given in the chat. I don't know if the webinar attendees can see the chat, but there it is. And I just would like to thank those that came here today, these speakers and these students as well. I really mean when I say that we are really delighted to have got this funding from the Royal Academy of Engineering, from Google, and we are really looking forward to having a cohort of students here in the summer. This is something that we've been doing for a few years now, and it's extremely rewarding for the students and also for us to see, to help to see and to see all these undergraduate students to grow in an area of work that's so exciting, that's going to have such an impact in all our lives in the years to come. So I'm looking forward to the application, and I'm looking forward to the summer. Thank you.